1248. Count number of nice subarrays. Given an array of integers nums and an integer k, a continuous subarray is called nice if there are k odd numbers on it. Return the number of nice subarrays. Example 1. Input, nums equals 1, 1, 2, 1, 1, and k equals 3. Output, 2. Explanation. The only subarrays with 3 odd numbers are 1, 1, 2, 1, and 1, 2, 1, 1. Example 2. Input, nums equals 2, 4, 6, and k equals 1. Output, 0. Explanation. There are no odd numbers in the array. Example 3. Input, nums equals 2, 2, 2, 1, 2, 2, 1, 2, 2, 2, and k equals 2. Output, 16. Since we only need to find the number of subarrays that contain a certain count of odd elements, we can ignore the numerical values of the elements and replace all odd values with 1 and even values with 0. Now, all we need to do is identify sequences of elements within the array whose sum equals the number of odd elements needed to make a nice array. Algorithm. Initialize integers cur_sum equals 0, subarrays equals 0, and a hash map prefix sum. Initialize prefix sum 0 with 1 to account for the initial value of cur_sum. Iterate over all the elements of nums using enumerate. Compute cur_sum as cur_sum equals cur_sum plus nums of I modulus 2. If cur_sum minus k exists in the hash map, increment the value of subarrays with prefix sum at the index cur_sum minus k. Increment prefix sum at the index cur_sum by 1 using get. If cur_sum hasn't been seen before, start with a count of 0. Return subarrays. Complexity analysis, let n be the number of elements in nums. Time complexity, O of n. We iterate through the array exactly once. In each iteration, we perform insertion and search operations in the hash map that take O of 1 time. Therefore, the time complexity can be stated as O of n. Space complexity, O of n. In each iteration, we insert a key value pair in the hash map. The space complexity is O of n, because the size of the hash map is proportional to the size of the list after n iterations.